So throughout chapter 10, we looked at how do we solve algebraic equations that are a little bit more complex. We also looked at toward the end of the chapter on how do we solve things that have two variables. So that was kind of like, if you think back to the very beginning of the year, that sort of relates to what we did in the first half of chapter 1. If you also remember in the second half of chapter 1, what we moved to is how do we represent how do we represent two variable equations on on a coordinate plane? Because a lot of times when you look at the coordinate plane, it gives you a way to kind of compare or to draw some other information about that particular equation. So the first thing we're going to look at here, we're going to look at in the first lesson, how do we graph linear equations? Just by way of definition, if you look at the word linear, it gives you a little bit of a clue as to what the word means. You can see the word line in there. So a linear equation is simply an equation whose solutions fall on a line on the coordinate plane when we graph it. So I've got a linear equation here. You see it goes up like that. In a straight line, it would have a slope of 2/3 because I go up 2 over 3. So these types of lines have a constant slope. So these types of equations have a constant slope. And so another thing we could say about them is that the slope is the ratio of x to y. So we're going to look at a couple of graphs here. We're going to review how to graph these because we did graph these in chapter 1, and we graphed them again in chapter 5 a little bit with the You're Hired activity. We did a little review on that. So we'll do a little review on how to graph these, and then what we're going to do is we're going to look at some linear versus nonlinear, kind of see how can we identify when an object is, or when an equation is linear, and how can we identify when it's not linear. So on the first equation here, we've got y equals 2x minus 3. The first thing I need to do, and remember we talked in the last slide about all the solutions fall on a line, we need to come up with some solutions. So to come up with these solutions, what we're going to do is we're going to make a t-chart, if you remember doing this. And remember, I can pick any numbers I want for x. Y is the dependent variable, x is independent. So I can pick whatever I want for x and y. So I'm going to pick, let's say I picked 0, 1, and 2. Just some easy numbers here. I pick low numbers. That means I can graph low numbers. And then I'm just going to plug this in. So if I plug in 0 for x, I get 2 times 0 minus 3. When I do 2 times 0 minus 3, y equals negative 3. So 0, negative 3 is one of my ordered pairs. To graph that, I go over to 0 on my coordinate plane, and I go down 1, 2, 3, and I'm going to put a dot right there. So there's my first point. Now I'm going to plug in 1 for x. So I get y equals 2 times 1 minus 3. Just run the math again. 2 times 1 is 2. 2 minus 3 is negative 1. So 1, negative 1 is my next dot. Again, I go over 1, down 1, and I get, there's my second point. And then just to make sure we're heading in the right direction, we'll do y equals 2 times 2 minus 3. 2 times 2 is 4, minus 3 is 1, so we have 2, 1. This is right here. So you can see these dots are all going up in a straight line when I connect them. Let's try and draw this as best I can. The other thing you'll notice about these, and this is something we kind of talked about in the You're Hired activity, as I move over, as I increase the x value by 1, my y value increases by 2. So the slope of this line would be up 2 over 1, which is 2, which if you look back at the equation, that's what we multiply x by. So our slope here is 2. We've got a straight line because all the solutions fall on that line. We're good to go. So let's see what happens if I have y equals x squared. Okay? So I'll choose my xy. Okay? I'll go 0, 1, 1 and 2 again. So if I plug in x equals 0, 0 squared is 0, so That's 0. If I plug in 1, 1 squared is also 1. 1, 1. But then look what happens when I plug in 4. So far, I got here, I go here to 1, 1. If I plug in 2, 2 squared gives me 4, which takes me up here. Now, I was headed off this way, right? But then this dot here has thrown everything off. So we've got something that is not a straight line here. So what I'm going to do, get rid of this. Whoops. Bring that back. That's not what I wanted to do. Get rid of this. No, it's not letting me do it. Well, anyways, what I want to do is I want to figure out what's happening. You see, it looks like we're starting to form a curve here. But I want to figure out what happens past this curve here, because it doesn't go straight down. So I'm going to pick a negative value here. So let's put 4 in here. Let's say I pick -1 and -2. Well, if I plug in y equals -1 squared, well, -1 times -1 is +1. If I plug in -2 squared, -2 times -2 is +4. So I've got -1, 1, and -2, 4. So what I have when I square this is not this straight line here. What I have is this curved line. That's terrible, but play along at home. This curved line that I formed, kind of like an upside-down umbrella, whenever I have squared. Now that's not linear. That's not linear. So this is a nonlinear equation. You'll explore that a little bit more in algebra. This is what we call a quadratic equation. So you'll notice in the first one, the first equation I graphed, this was just 2x. Well, here I've got x squared. So if I have something that's squared, that's one sign that we're not going to get a linear equation. We're going to get this curve here. All right? So this is not linear. This is linear. Let's move on. All right, let's see what happens if I have a fraction here. Now, be careful when you pick your numbers. So you can pick whatever numbers you want. So if I picked 0, 1, and 2, well, if I put 0 in here, that's going to be pretty easy. So I got y equals 2 times 0 over 3. So that's 0 over 3, which is 0. So 0, 0 is on my graph. That's pretty easy. If I picked 1, though, I'd have 2 times 1 over 3, which would be 2/3, and that's kind of hard to graph. So what I'm going to pick instead, I'm going to pick a number that's going to allow me to divide by 3 evenly. So let's say I just choose 3. Well, if I do 2 times 3 divided by 3, I get 6 over 3, which is 2. So I can do 3, 2. Okay, and then let's just plug in -3 as well. See what happens. So y equals 2 times -3 over 3. -6 over 3 is -2. So -3, -2. And you'll notice I've got this line like this. Whoops, I graphed that last one wrong. Let me move this one down here. Okay, and then I'll connect the dots. We've got a linear equation. Notice the slope. Slope is I go up 2 over 3, 2/3, just like that. Okay? All right, one more. What about if I don't have an x value? Well, what does that look like? Well, if you think about your t-chart here, if I plug in anything for x, y is always 3, right? So it doesn't even make sense to fill in a t-chart, because if I say, well, x is 0, well, it doesn't matter. Y is 3. There's no x to plug in here, right? So y is 3 is up here. So no matter what, my equation is always y equals 3, no matter what value. So all these dots going in here are all on the equation of y equals 3. Notice they all form this horizontal line right here. And there you have it. Okay? It's a linear equation. There's nothing squared. There is another way that you could get There is another way that you could get a nonlinear equation. We're not going to touch on that today, though. But you'll hit it, like I said, you'll hit on that again next year in algebra. But that's a good exploration for now. So go ahead and try some of this graphing stuff in the work below, and let me know if you have any questions.